So, hello. Maybe let's wait 1 or 2 more minutes before we start. Okay, hello. My name is Lukas Wolter. I'm cloud architect at Prodina. I'm one of the lead architects for the data center and migration and modernization topics. And today I will talk about Azure Arc for hybrid infrastructures. Just for organization, if you have questions, there is a questions button. So please write your questions to this area and I will answer them at the end of the webinar. So Azure Arc for hybrid infrastructure is the topic for today. I've split the topic in 3 parts. I will start how we manage servers and clusters. So I will give you a general overview. Then I will show you how we join resources with Azure Arc and how we enable Azure services on Arc-enabled resources. And I will talk a bit about the licensing and the extended security updates. In the next area, I will talk about cloud-native software development, how we can use extensions like Key Vault, Open Service Mesh, GitOps with Flux, and also how we can benefit from ARC. And in the last part, we will talk about platform as a service offerings. I will give you a general overview about the concept, and then I have an example with the Azure SQL Managed Instance, which we will show how to deploy it on your own infrastructure, where we can decide between the indirect connected mode and the direct connected mode. So let's start with a general overview. And here we should talk a bit about hybrid and migration challenges. So at the end, hybrid is the norm for the most of our customers today. This might be because customers operate in regulated industries or due to the need of latency requirement. But it's complex. And we often hear customers say they need to have a visibility into the health of all their existing as well as the future infrastructure and applications in a single pane of glass. So from IT point of view, while organizations understand the need for implementing a governance standard, they find it hard to integrate on-premise policies and updates with their cloud infrastructure. Also, we often have different app development teams in the organization. There exists a wide range of skills across on-premise and cloud. What we see very often is that the customers are looking for consistent interoperability between the two so they can unify the development practices. And also on the application development side, many of you want to speed innovation. at the end, regardless of where your apps run, if it's on-prem, multi-cloud, hybrid, or edge. And nearly everyone wants to tap into AI or IoT these days to improve the operations. So in general, Azure Arc is a bridge that extends the Azure platform, which means services, data, tools, and so on, to all these locations. With Azure Arc, customers can use Azure hyperscale services with their existing and new workloads across public clouds, core enterprise system, in data centers and branch offices, and also in the operational edge. They can build applications and services with the flexibility to run across multiple environments. They can also deploy a subset of Azure services for application, data, and AI locally on a variety of hardware, integrated systems, visualization platform, VMs, Kubernetes cluster, and also industrial IoT devices. So in the first step, Azure Arc can be connected to your existing infrastructure environment. It might be VMware, Nutanix, Hyper-V, but also cloud providers like AWS or Google Cloud Platform. So you can connect your existing infrastructure and spin it up in Azure. Also, if you migrate to Azure, you can use Azure Arc for all workloads that have not been migrated yet. This gives you a single control plane for all the workloads with a consistent overview over your resources, with your inventory, and the change tracking. Additionally, we can use GitOps practices, for example, to work with our Kubernetes clusters. In the next step, you can deploy services downwards in your environment. So means from Azure to VMware, Nutanix, and so on. And Azure Arc enabled servers lets you manage Windows and Linux physical servers and virtual machines hosted outside of Azure on your corporate network or on any other cloud provider. The management experience is designed to be consistent with how you manage native Azure virtual machines using the standard Azure constructs such as Azure Policy, Microsoft Defender for Cloud, Azure Update Manager, Microsoft Sentinel, and Azure Monitor. So you have a consistent way to manage to run all the servers everywhere. So with Microsoft Defender for Cloud, you will get a unified visibility into your cloud security posture across Azure, AWS, Google Cloud, and also hybrid clouds. So you can prioritize the most critical risks. With Sentinel, you can see and stop cyber threats. With Azure Policy, you can archive real-time cloud compliance at scale. With Azure Monitor, you will gain the end-to-end observability for your applications, infrastructure, and network. And with the Updates Manager, you can centrally govern and manage software updates at scale. And in the third part, we can deploy and run Azure services outside of Azure while still operating it from Azure. So this means we can run data services, for example, on our on-premise Kubernetes environment, and they feels like as they run in Azure. And we can also deploy app services with web apps, functions, and logic apps, and also an event grid on Kubernetes. So let me show how we do it. So when we join resources to Azure, we can go do it completely via the portal and start if we navigate to the Azure Arc area, and there we can select the manage resources or add resources. Here we need to select what kind of machine we would like to add. We can add servers, VMs, and also, for example, Kubernetes clusters. In this example, I will show you how we add a single virtual machine and single server. So here we click the Generate Script button, which will open a dialog where we need to add the meter informations where we would like to place it in Azure. So we need a subscription, we need a resource group, we need some server details for the location because also Microsoft stores the metadata. Due to GDPR, we should select the same region where the real machine lives. And We can also directly connect SQL servers. They will be detected automatically if we add this checkbox. In the next step, Azure will generate a script which we can just copy and put it on the server we would like to join. So in this case, it's an Amazon Linux machine where I just connected on the terminal and copied the code. When I execute the code, it will download an agent which will be installed on the machine, and it will ask me to open an URL for the device login with a code. I can also do it with a service principal. So when I need to add a bunch of servers, I can use a service principal. So I don't need to use my personal user for it. But in this case, we log in and we just connect the machine to Azure. When we click the next button, we will complete the joining process and the machine will appear in Microsoft Azure. So with this step, I added the machine and I can now see and browse it in Azure and have it in my inventory. In the next steps, I can start to enable Azure services on these machines. So there are a bunch of services which can be added directly. So it's, for example, the update manager, monitoring, the insights, policies, change tracking, inventory, security stuff, and also SQL Server configurations. To do this, we can do it directly on the machine configuration, where we can activate, for example, the built-in policies for Arc-enabled servers or Kubernetes cluster. We can start to tailor these policies to align with our specific compliance requirements, and we can also create and assign custom policies. For the updates, we can enable the periodic update assessment. So the agent installed on the machine will check if we have updates available and will highlight the updates separated in security and critical updates and other updates. And we can also do it directly from the portal with a one-time update button, or we can do it on a scheduled way, for example, once per day or any night. Or, of course, we can use the Azure Update Manager, where we can oversee the compliance for our entire fleet through a single pane. So it's a native functionality of Azure which we already know for the Azure virtual machines. But here we can bring together and get a single pane of glass over the Azure VMs and also the Arc-enabled servers. Here we also have the functionality to have periodic assessments, and we can also enforce the stuff with Azure policies. And also a good thing is that we can create custom reporting dashboards which will fit to our needs. Also a great feature is the change tracking. So we can track changes on our virtual machines and also Arc-enabled servers. So this will help us to pinpoint operational and environment issues. So it will track Windows software, Linux packages, Windows and Linux file, registry keys, services, and also Linux daemons. And you can see here, for example, on this machine, I installed a Docker daemon. So in the change tracking, it's visible as added, and also due to the updates, we see that some other packages were modified. So if we have issues with machines, we can also do it on an automation account for our whole fleet and drill down and find operational issues over our whole fleet. With Defender for servers, we can add threat detection and advanced defense to Windows and as well also as on Linux servers. And we will get compliance benchmarks mapped to the industry standards. So it will be also added via the portal. We can also add a policy that they will be added automatically. And it will show us also recommendations. It has just-in-time VM access, and it will block malware and adaptive application controls. So it will set guardrails with the Azure policy integration and will help us to improve our security also on the on-premise or hybrid platform. With the Azure Monitor, Azure Monitor tackles the importance to have monitoring available out of the box and to get easily started with samples and recommendations, including effective alerts, optimal queries, and customizable reports. So Azure Monitor brings us also an observability solution for cloud and edge workloads, and it works just across Azure and the edge in one tool. So you have the ability to observe at any level across the stack. Azure Monitor offers an open, extensible platform for innovation and really enterprise ready for mission control scenarios. So at the end, it starts with collecting the telemetry, and Azure Monitor is able to collect the data from application, network, infrastructure, and you can also ingest your own custom data. So all the data is stored centralized, and we can fully manage logs and metric stores. So question is what we can do with this data. And typically we start with the insights, which are end-to-end experience we have to put together for canonical scenarios or resources such as application, containers, VM, network storage, and so on. Insights provide us guidance and help troubleshoot the root cause of issues, and we can really quickly drill down. Also log analytics is also a capability we can use here. And in the next slide, I will show you that we can also use Azure Arc to have a single consistent view of all our SQL servers. So we are bringing more Azure data manageability to SQL Server on-prem and also for multi-cloud customers. At the end, there are three capabilities that most customers care about. It's management, governance, and security for the SQL workloads. We can manage all SQL estate with Azure Arc and using Azure, and we will get a single view about all the servers in a central portal, which help us to better manage our inventory and also the licenses. Azure also provides us best practice analyzer to automatically evaluate SQL servers like security, performance, scalability, business continuity, and more without additional costs. So it brings us a single view and the fully automatic assessment for the management area. For the governance, we can have purview access policies. It's not a full purview integration, but we can use parts of it. And for security also, there is Microsoft Defender available for. And what's really cool is the single sign-on feature with our Active Directory is supported now. Also, the license model changed a bit. So we can now use pay-as-you-go licensing per core per month. And the price for it is for the standard edition $73 and for the enterprise edition $274. For all the stuff I showed you, the pricing is also interesting because the base stuff is for free. So we can add our servers and benefit from the inventory, tagging, ABAC, and the resource graph functionality for free. For the other features like Microsoft Defender for Cloud. For the base plan, plan 1, we pay $5 per server per month, and for the plan 2 with additional functionalities, it's $15. Azure Monitor is $2.30 per gigabyte per month, so it's pay as you go. So we will pay as much for logs and metrics we send to it. Sentinel is also available with the AI-empowered data analysis, and it's $2 for gigabyte. The update manager is $5 per server, and the guest configuration with Azure Policy is also $6 per server per month. As the next topic, I will talk about the extended security updates, and here we have the possibility to enable them directly in the portal. So with the Azure Arc extended security updates, there's a flexible monthly billing model provided with keyless activation, allowing you to take advantage of the extended security updates on premise and also gain, like I described before, from the other services when you add the machines. To create new license, we can simply do it in the portal. We need to press the create button. Then we can select servers without an extended security update enabled. We can link the license to the new server, and in the next steps, they will directly appear with the ESU enabled. When we come to the cloud native software development area, we will now go a bit more in the technical level. So when we have Kubernetes clusters on premise, it's sometimes hard to spin up the stuff completely on premise, to add GitOps processes and all the best practices with using vaults and also service meshes and so on. So it's sometimes painful, and you need a bigger know-how or more know-how in your teams to have this base set up, which enables you to operate services on Kubernetes. And here I will show you how you can add a Kubernetes cluster to Azure to get an Arc-enabled Kubernetes cluster, and how we can then enable different extensions to work with a GitOps model and benefit from different other Azure services. So to connect Kubernetes cluster, we have an AC command line extension. So we need to be connected with our Kubernetes cluster locally. So we need a machine where we can interact with the Kubernetes API. So, for example, with kubectl, kubecontrol, when we can work with kubecontrol, we can do this command. The AC command uses a local kubeconfig to deploy resources to the cluster. So we will use the AC connect Kubernetes, and we will hand over a resource group, a name, and a location where we would like to add a cluster. And the command line tool will start to install or apply a Helm chart, which will install Azure daemons, which will do the connection to Azure. When we join resources to Azure Arc, it's always that we don't need to open something to be accessible from the outside. It's always a communication from the server to Azure, and we just need to whitelist the communication from our resources to the Microsoft endpoints in our firewall. After we execute the command, the server is directly visible in our Arc area in the Kubernetes area, and we see it here. And we can directly start browse it like we do it with normal native AKS cluster, so Azure Kubernetes Services, which is the cloud version from Microsoft. And we can also here start directly to assign policies. We can also write here policies or custom policies again. We can just enable the GitOps Flux extension, which allows us to use GitOps flow. So we add our Kubernetes cluster to the as an Arc and connected Kubernetes cluster. Then we enable the Flux, and then it will be connected, for example, to a Git repository, which might be on GitHub. And there's a controller which will check our Git repository for configurations. And every time when we do a change on this repository, Flux will verify that there is a change. It will pick it up and it will compare if there is a change for our application. And for example, if we do an update for a service from version 1 to version 2, it will recognize the change and will be automatically update the cluster with a rolling update to the new version. So we don't need to have access to the Kubernetes cluster anymore as a developer, for example. We just need to change code files where we have then revision on it. We can have for us request approval steps with merge request and so on. Also, I would recommend to use the keyword extension, which is also just an extension we need to enable via the portal. And then we can add a keyword where we can put our secrets and certificates to. And this helps us to put the secrets in a key store where we can have access policies on, and they will be sent to the cluster automatically. There is a controller which will be installed on the cluster, which will pull the secrets to the cluster to make it available as a secret where our services on the Kubernetes cluster can mount it and start work with it. And in the last step, I would recommend to use the Open Service Mesh extension, though it helps us to uniformly manage, secure, and also get out-of-the-box observability for our cluster. So this means, for example, blue-green deployments are directly available. So we can do a change, we can deploy a second version, and we can start, for example, to add a rule which will route the traffic only for 10% of the traffic to the new service. We can check how the application will behave, and then we can increase the traffic amount until we have it completely switched to the new version, and then we can remove the old version again. So it helps us with best practices just by activating these extensions in Azure. Okay. And just this. Daniel, you raised the question about the inbound traffic. Can you be a bit more precise? I'm not sure on which area you asked the question. So maybe just write it down. I will answer it later. Okay. For the data services, With the Arc-enabled data services, we bring the best of Azure with its cloud data management capabilities to any infrastructure. So no matter where the infrastructure lives, this could be on your existing on-premise environment, in other public clouds, or even at the edge, like we see it sometimes in retail or manufacturing customers. The services can run anywhere and bring a much needed streamlined experience across your data workloads. So Azure Arc enabled data services will deliver an always up-to-date experience. End of support can be a thing of the past with it. So you can benefit from an evergreen SQL environment with the newest features and automated updates without downtime to maximize efficiency and minimize disruptions. We will get the industry-leading multi-layered protection with the built-in security, also with the comprehensive encryption, including transparent database encryption and always encrypted, as well as ABAC and policies. So we can optimize the performance of the applications by scale it up or down based on the application need without the downtime required. With the licensing, we paying only for what we use. So if we scale up, we will only pay for the time, and when we scale down again, it's the lower costs again. So yeah, these features are fully supported, and we can differentiate between a direct and continuous connection to Azure. So I will explain it with a few slides now. When we need again a Kubernetes cluster, like I described before. So we need to have an Arc-enabled Kubernetes cluster, of course, with storage, persistent storage attached. In the next step, we will deploy the data service operator, which is the interface to the Kubernetes API. And it has built-in automatic updates, monitoring, backup, and of course also point-in-time restore. It's responsible for the communication with Azure for the inventory, optionally the logs and metrics, and of course all for the advanced data security policies. What we here see is the indirect connected mode. So we don't have a direct connection to Azure. So this means we need to pull the images from Azure Arc and push it into our private registry. Then we need to configure the Arc data services to our private registry, and we can do a local deployment with an extension in the CLI or in the Azure Data Studio. In this scenario, the telemetry data we need to extract with a CLI command and upload it to Azure as a file. So we can use jobs for it, for example, because we need information for the billing and so on. Additionally, we can also send logs and metrics to have it, for example, in a log analytics workspace or in Azure Monitor. And the direct connected mode will give us the feeling that our managed instance or PostgreSQL, for example, is a native Azure resource because we can operate it from everywhere. We have the same usability like native Azure services, and we can browse it in the portal like a normal resource. But the data is completely on-premise or in our own environment at the end, and we have best from both worlds. How we can set it up, it's also again straightforward. We need to create a custom location in Azure, and we need to enable the data service extension on our Kubernetes cluster, which will install some resources on the cluster. And we need to deploy the Arc data controller via the marketplace. So we can just go to the portal, to the marketplace. We can decide if we would like to have the Arc-enabled Kubernetes cluster with the direct connected mode or with the indirect connected mode. And depending on our selection here, we need to add different meter informations. And with the what I'm showing now is the direct connected mode, which will do the connection via the portal in this case, or we can also just copy again a command for the Azure Data Studio for the indirect connected mode. Here we add again some meter informations like the subscription, the resource group, the controller name, and it will be deployed when we click on the create button, and it will create the pods for the data controller. So for monitoring, the metrics, the point in time restore, the updates, and so on. In the next step, we can select the database we would like to create again in the marketplace. So we go to the marketplace and then we can search for Arc-enabled managed instance. And here we type again our instance. So we need to select our Kubernetes cluster where the data controller is installed. If we would like to connect via load balancer or via node port, the sizing of the instance, we can add the administrator account informations, and then it's just again a creation command which will add a new deployment. In this case, we see the demo SQL 1 deployment, which deploys 3 pods, and also the install will directly appear in the portal, and we can use our alert rules. We can browse the metrics and the logs directly from the portal. So at the end, it looks like a completely Azure native managed instance, which is completely hosted on premise. Okay, this was the presentation. We have saved some time for the Q&A, so feel free to write your questions to the chat. Okay, Daniel, you specified it a bit more. Yeah, this is the idea of Azure Arc. It's that the data stays completely on-premise, so you have the workload on-premise, and only you can send metadata to Microsoft. So, for example, when you just add the servers, you will only get the meter information to have the inventory. So you can see all your workloads, but the machine itself and the data will stay on-premise. Additionally, you can then use the Azure services to improve stuff, for example, the update manager and so on. And for the data services, for example, if you are asking, for example, the managed instance, you can use the connected or indirect connected mode, where you can have a connection to Microsoft to have the Azure native feeling, where the meter information can be sent automatically to Azure. And also you can decide if you would like to have, for example, logs on Azure or keep it completely on-premise. And for the indirect mode, you need a job. It's just for the billing. So Microsoft needs to know the amount of cores and so on. So you need to extract the information and send it periodically to Microsoft and upload it so that they can create a bill at the end. Answers this your question? Ah, perfect. So do we have more questions? If not, I can also write you my email address here. So you can also raise your questions afterwards and we can do a separate exchange later on. Okay, so if there are no more questions, I will end the event now. Thank you for joining. Have a good day and see you next time. Bye-bye.